Emergency Power System Installation Acceptance. This is from NFPA 110, 2010 edition, Chapter 7.13. Some have referred to this as a new generator birth certificate. All information expressed by Standby Power Solutions, LLC, or its officers, is strictly the opinion of Standby Power Solutions, LLC. Life safety is the reason for NFPA 110. Return on investment is the reason generator manufacturers exist. NFPA 110 is excellent. It is written and maintained by industry insiders who know all of the tricks of the trade. The goal is life safety. Life safety is enhanced by enforcing code compliance. The code writers have included certified test requirements. At the time of the installation acceptance test, EPSS suppliers are required to make available to the authority having jurisdiction 4 specific certifications or documents that assure the equipment was factory tested and the tests were observed by outside testing laboratories. These documents are, number 1, evidence of prototype testing, 2, a certified torsional vibration analysis, 3, a letter of compliance with NFPA 110 from the supplier of the power system, and 4, certification of performance at rated load and rated power factor. As a surveyor, you do not have to be a generator expert. All you have to do is just collect the documents from the experts. The first document deals with prototype testing. Prototype testing was introduced in the late 70s. It was a good idea. Many generator sets were built on back lots with very little engineering involved. To build a generator set, assemblers match an engine to a generator end and then bolt on other items like radiator, fan, alternator, control panel, and exhaust system. The generators work, but premature failures occur as these unmatched parts individually fail. Some parts even fall off due to makeshift mounting arrangements. Most generator factories now engineer each model to work with matched components and then test the complete prototype system to the point of failure. All subsequent models are built using the factory matched components, assuring greater reliability over mismatch assembled generators. Prototype testing is now the standard. Prototype testing can be expensive. Anytime an option is added, the prototype test needs to be repeated to include the new modification. In the photo on the left, you see a controller that worked perfectly in the 12-volt version, but when the 24-volt option was taken, it caused damage to the starting system. In the center, you see a latch on a door that has failed. Now that little latch at the bottom caused the door to be impossible to remove and it wouldn't go back in its normal position. That door weighed about 50 pounds, so this exposed the operator to injury. On the right, you see leaking fuel tanks. When these tanks were filled and they leaked, some at the well, some at the plug in the bottom, they would contaminate the soil around the base. The soil then had to be removed and disposed of. Many potential failures can be found and corrected by prototype testing at the factory. Be sure to get the documents. The generator needs to operate reliably throughout a power outage. Life safety depends on that. Here are some failures I have seen that would have turned up during prototype testing. These can shut the system down when it is needed most. On the left, the top picture shows a spring. That throttle control spring failed. It would fall off, and then the generator would slow down and not produce power. Directly below that, you see an exhaust system. The factory used a stick-on insulation in order to prevent burning of the paint on the outside of the enclosure. That insulation would come loose. It was made out of plastic. It would fall down on the exhaust system and catch fire. In the center top, you see an air cleaner that cannot be removed. They put the enclosure up in such a way that you cannot pull the air cleaner element out all the way to change it. In the center bottom, there's a battery with a battery hold-down clamp way too close to the positive terminal. After a few months, that positive terminal bleeds over to the battery clamp and therefore to ground and causes battery failure. On the upper right, that's an incident of wet stacking. That's where the engine allows oil and excess fuel to go into the exhaust system, and it runs down looking like a tarry, gooey mess. This tarry, gooey mess can accumulate on the exhaust valve stem, preventing the valve from seating properly. Therefore, you have a loss of compression and engine failure. Now, on the right bottom, that's wiring that rubbed through to that metal that it's right next to, causing the machine to shut down on high engine temperature. It's just that the wiring insulation was too soft. The second document to get is the certified analysis. Now, this refers to the torsional vibration analysis as specified in Chapter 5.6.10.2. The rotating and reciprocating parts of an engine, like pistons, connecting rods, flywheel, and crankshaft, may weigh more than 1,000 pounds and naturally create vibration as they move at high speed. The generator main rotor may weigh more than 1,000 pounds as well, and no matter how well they try to balance it, it will create its own vibration as it spins. When these two vibrations match up, they tend to amplify and cause damage. The generator manufacturer can analyze these vibrations and take steps to prevent them from doing damage. Damage from vibration can show up just about anywhere. On the left, the top picture shows a crack in an exhaust system. That's a muffler crack. Down below, it shows a similar muffler with the same kind of crack, but it shows where the soot from the exhaust emissions have caused damage and dirtied up the rest of that muffler. Now, on the lower center, you can see the radiator has been covered with the soot from the exhaust coming out of that broken muffler. It causes the core to be clogged with oily, sooty debris, and eventually that machine shut down on high engine temperature because the air couldn't flow over the core to cool the engine. In the upper center, that's a rain cap laying on top of the generator enclosure that vibrated off. The picture on the right shows another one with the rain cap actually laying there on top of the enclosure. It shook so hard it broke the hinge on the rain cap. As you can see, torsional vibration can cause serious damage. Other damage from vibration can include bolts shaken loose, broken crankshaft or generator shaft, mounting brackets broken, fan drive failure allowing the fan to come off and damage the radiator, and control panel damage. As you noticed, item 2 called for certified analysis. The term certification has specific meaning. It is required for torsional vibration analysis as well as the load test at rated power factor as noted in NFPA 110. Typically, this requires the manufacturer to hire an outside accredited engineering firm that specializes in certification. Documentation that appropriate procedures have been successfully completed should follow and be made available to the authority having jurisdiction at the time of the installation acceptance test. Document number 3 is the letter of compliance. A letter of compliance must be made available to the authority having jurisdiction at the time of the installation acceptance test. This letter must be from the supplier of the emergency power supply system and stipulate that the entire unit complies with NFPA 110 and performs according to the requirements of NFPA 110 when installed. This requires the engineer, contractor, and vendor to acquire a copy of NFPA 110, read NFPA 110, and make every effort to understand NFPA 110 before they deliver the system to the end user. This letter will clear up a lot of problems and assure the owner of the highest reliability possible. The fourth document has to do with rated load test at rated power factor. The manufacturers hate this. A standby generator's power factor is designated 0.8. I'm not going to explain power factor in this article, except to say that it has to do with how much the rotor in an electric motor slips. When you put a load on an electric motor, it slows down a bit from perfect synchronization with the power source. The degree of slippage is designated as power factor. It takes more energy to operate a generator at any power factor lower than 1.0, or unity power factor. The greater the load on the motor, the greater the slippage, and consequently the harder the generator has to work. Therefore, in order to get a true picture of a generator's capability, it has to be tested at its rated power factor. A standard resistive load bank, like almost every generator company has, cannot test at rated power factor. That takes a reactive load bank. Most generator manufacturers have reactive load banks at the factory. As a result, the test at rated load and rated power factor must be conducted at the factory and certified results supplied. Chapter 7.13.4.3 specifies a full load on-site test may be conducted. It allows this test can be done using a resistive load bank, provided the full load test at rated power factor was conducted at the factory and supporting reports provided. By demanding these documents, you put the vendors and contractors on notice that you expect them to comply with the building code in order to ensure life safety and protect occupants and owners. Compliance with NFPA 110 is legally required by almost all municipalities and states through their individual adoption of International Building Code, International Fire Code, and Life Safety Code. Compliance is also required by all engineering specifications and contractors' licenses for the benefit of owners. This compliance is the responsibility of the contractors and the engineers. Facility licensing and insurance liability coverage requires compliance with these same codes. Get the paperwork. At the time of the installation acceptance test, you are to be provided with the prototype test report, the torsional vibration analysis certified, the letter of compliance from the supplier of the system, load test at rated power factor certified. Note to surveyors, testing and certified test reports are expensive. If provided, these additional costs can cause the vendor to be less competitive in the bid process. If one or more bidders opt out of providing the required reports, it is likely that one of those bidders will be successful. In addition, always check to make sure the model and serial numbers on the test reports match the model and serial numbers on the actual equipment you are surveying. All information expressed by Standby Power Solutions, LLC, or its officers is strictly the opinion of Standby Power Solutions, LLC. Standby Power Solutions, LLC disclaims any liability for any personal injury, property, or other damages of any nature whatsoever, whether special, indirect, consequential, or compensatory, directly or indirectly resulting from the publication, use of, or reliance on this website or any information derived thereof. Standby Power Solutions, LLC also makes no guarantee or warranty as to the accuracy or completeness of any information contained herein. Anyone using this website should rely on his or her own independent judgment, or, as appropriate, seek the advice of a competent professional in determining the exercise of reasonable care in any given circumstance. All rights reserved. Do not reproduce without express written permission.